what's actually inside of the blockchain block, because what's inside the block is probably pretty important to know about, especially if you're going to be tinkering around with this and playing around. So basically the good part is that they're pretty common between the Ethereum block and the Bitcoin block and what's in there. Some of it's data, some of it's metadata. So it makes it really kind of interesting on what's in there depending on what you've got. So if you're programming your own blockchain software or system, understanding these fields is really kind of the important part. You know, again, the timestamp, block number, any kind of base fee per gas if you're using gas for a transaction to be included in the block, the difficulty, the unique identifier for that block, and then the unique identifier for the block that came before this. So this is how we link blocks in a chain, right? So current and parent, all the transactions that are included in the block, and that's really the interesting one, right? For me at least. That one's got all the cool groovy data in it. It should be treated as text, and that's a big one. And then the state root, entire state of the system, what's going on, how does it look, any kind of other things that are inside that. And then the nonce, that is your mix hash, which proves that the block has gone through proof of work. Nonce is the critical component of this and has to be accurate. So data fields in a Bitcoin block, same thing, right? Field description is a block size, block's header, transaction counter is different, and how many transactions are in that block. And then transactions recorded in the block is the interesting bit for that. And then version, previous block hash, Merkle root, and then all the other things that you would do to find out its position within the chain. And then again, that nonce, that proof of work algorithm, and then the difficulty target. So what really makes this kind of interesting as you kind of go through this is that what's considered metadata and then what's considered actual block data. So you have data about the block and then you have the transactions field. So that's why I say the transactions field is probably the most interesting of them all. The rest of this is all just really just basically operational data. So in general, your block data, your metadata is going to be the block header, right? And it helps verify the validity of that block. So the typical block metadata contains the current version of the block structure, right? And it may be something where we're doing proof of work, and maybe where we're doing something else with it. So again, what version are we working with? Whether it's Web 2, Web 3, outlined an update, whatever we've got going. Previous block header hash, this is the parents block. This is how we get the blockchain. That has to be pointing to the block before it. And then your block, the Merkle root hash is basically the cryptographic hash of all the transactions included in this block. And so basically you take your transactions field and make a hash of that. And then the time the block was created, and then the difficulty that was used to create this block, and then nonce, the number used once. It's the random value, and that's how you do your proof of work. So really when you're guessing at your terabit, your tera hashes per second. It's all about that nonce. The random value of creator of block is allowed to manipulate however they so choose, but that is how you get your validation. So that's basically your block header. The rest of the block is going to contain transactions the miner has chosen to include in that block. And again, it pays to have as many transactions in that as possible, because remember, each transaction has its own transaction fee. So remember that. I mean, some of these blocks can be like super crazy expensive as terms of reward. So something you need to know. So again, how that block is constructed. So previous block hash, Merkle root, timestamps, all that metadata goes at the top of your block, and then everything gets munched in there. As many transactions as you can to fit into that 1 megabit size max, right? And that is an artificial construct that we're going to set our block size to 1 megabit. So as long as your metadata only takes up so much, the rest of this thing can be shoved full of transactions, and each one of those transactions will have a transaction fee. So kind of neat. Some of these things are going to be more expensive than others. So for me, that transaction field is really the more interesting one, right? And they say it's the smallest of the building blocks, but really, in all honesty, this is where you're going to hold your data: the sender address, recipient address, what was sent, how much it was sent, what it's worth. And that can actually be really kind of interesting. Each one of those transactions has a transaction fee. So when you put this into the blockchain, that's essentially what you're doing. You're adding to that ledger, and then that validates that Tony sent money to Andre. Right, so I kind of like that idea when we get into our example down here, that each transaction involves the value of some Bitcoin moving from one address to another. So Tony wants to send Bitcoin to Andre, then transactions will move to Bitcoin value from his address to their address. So what's interesting about that is that there's a transaction fee for that one specific thing, and you roll up all of the transaction fees into that one block. So if you can hold 248 transactions in that block, and each one has a transaction fee of $100, and just some arbitrary numbers coming out, right? You have 248. The block is worth $24,000, right? In terms of what the transaction fee is. If you have 240 transactions, 248, 240,800. So again, it's that idea of the more you can shove into the block, the more interesting this is. So you validate the block, but that output of the transaction will be in that public key block, and then the Bitcoin will be sent. But again, once that transaction gets verified, then Andre will receive his Bitcoin, and that transaction fee was paid for. So the miner in standard gets that transaction fee, gets those rewards for doing that. Of course, there's probably someone else in there, but that's where this gets to be interesting with the transaction field. And that's why the transaction field is so interesting to me, because you can get into some really interesting amounts being moved around, but each one of those has that transaction fee. So the more you can stuff into the transaction field, the more that block is worth, technically, as you kind of go through it. So transactions are interesting, right? You do have your header, you have all the things that would go in here, the things that make it a valid block in the ledger. But where you're really making your money is try to stuff as many transactions in that transactions block to make it work for you. So that's really the cool part about that block header, and why understanding what goes in the block is so important on this one, and why it makes this such an interesting bit for a miner. Again, that max block size of 1 megabit. If you could increase that max block size, you can put more transactions in there and just generate more rent, right, off of your system, which is good when you're doing proof of work or you're doing anything else along that line. So blocks between networks have a common architecture, right? They all have that same header, but then they do have some interesting things that they belong individually. So things like for Ethereum, gas, and other stuff, Bitcoin, something different, right? But the really interesting component is that transaction block. And that's where you want to shove as many transactions as you can in there to validate that data, use it as a ledger, get the money moved around, but you're also getting some rent off that one because you're rolling up all those transaction fees into that one block. It is an interesting way of making money in this system, right? And one of the reasons why if you can run this kind of thing, and proof of that consensus proof really makes for a more interesting process when you start really digging into how this works and where the money really lies in this system. The money really lies in the Bitcoin, but for rent-seeking behavior, you're going to really try to do as much of this transaction fees as possible. And the transaction fees can really make the block a lot more interesting, especially if someone's really in a hurry and is willing to pay a premium transaction fee. So something to think about, right? Again, that max block size of 1 megabit, though, just puts a limiter on it, puts some brakes on it, but that's what's inside the block. So what's inside the block is actually really interesting when you go through it. So hopefully you guys like this lecture, and I will see you in the next one. Kind of short this time.